Hello, I'm SpockDev, creator of a game called Drift On. It has fracture and ground. Yeah, we can see it better while playing. Many people asked how I implemented it. The short answer would be track consists of tiles. Each tile is a 3D model. I break it in advance and then animate it with vertex shader in real time. So I will show you how you can do it yourself, make it work in Unity. So first we need to actually break 3D model. We'll use Blender Fracture Modifier by Scorpion81. You can download it from here. I've already installed this Blender. So let's select everything, delete, Shift A, create cube. Cube will be our tile. Then we go to modifiers, add fracture modifier, go to physics settings. We will select shard count, let's say 50, execute fracture. You can see it. To see it, we need to enable wireframe. So it's already broken. Yeah, it's still one object. To actually make 50 objects, you need to convert to objects. Now we have 50 separate shards. Let's choose one. Kind of looks like this. So then you can import it to Blender. I've already done it. Look like this. Shard. Create it to the scene. First is unbroken, and then separate pieces. So first easiest way would be to make it animate. We just can use Unity physics. So we choose all shards, add rigid body, use gravity, and add mesh collider. Make it convex. Add floor. Actually, let's create it. We'll use cube as a floor. Make it, increase it. Like this. Then run it. So yeah, it falls apart into pieces. So it doesn't require any code. You can have like unbroken piece. Let's say you like shoot it and hit it, then you change in code to this object with a bunch of pieces, and it breaks, and physics does all the work. So main problem with this is we have dozens of mesh colliders, and they're fairly expensive, and I think they have to be convex, otherwise they would have like more limitations. You can read more on the Unity documentation for physics. So what if we don't need physics, but we need more performance? The implemented example, it can, what if we need something like this? It kind of explodes. We shoot it, kind of explodes into pieces. They like disappear. Yeah, let's see how it is implemented. Let's make it through script. We have our pieces, array of our pieces. In start, we remember the initial position and rotation, and in update, we go through each piece. So our explosion looks kind of like this. Let's say we have our complete object. Here piece, here center of object, and for simple explosion, we just move each piece in center from direction. Move here and like every other piece, kind of like this. So we're our direction from center, it's essentially local position normalized. Then to move, we change position in this direction by some translate amount, uh, how much we will move it, and fracture amount essentially goes from 0 to 1. It's like 1 is 100%. We also scale it. It goes from full scale to like 0 based on fracture amount, and we rotate some amount. I will have rotate amount Euler multiply by fracture amount, make quaternion, and to apply quaternion we have to multiply. So it looks like this. You can actually build on top of it. You can implement gravity, so it would fall with time. You can like make it explode not from center but from some certain relative point in space, like you have a explosion here, so direction would be here. Advantage of it, we don't calculate expensive physics. We can actually implement some like interesting behaviors that we won't get with physics. Yeah, you can optimize it even more. You can calculate transformations in job, multi-threaded, and then apply it on the main thread. But still, there is a problem that we have 50 different pieces. So we have 50 draw calls. I think correct term would be set Pascal now. We can use dynamic batching for it to have like to batch draw calls together. But dynamic batching has certain overhead performance, and it works with our simple pieces, but we have more complex, it won't work at all. And static batching don't work because they're not static. GPU instancing won't work because they're all different. So we can the way we can improve it, optimize it to fracture on GPU. So we combined all pieces in one mesh. It would look kind of like this. Kind of it's combined, but still from broken pieces, and move on GPU. So it would look kind of the same as before. First of all, we need to combine it. Not just combine all the pieces together, but each vertex would have to know piece it belongs to. Kind of by default, let's say our piece from 4 points for vertices, by default they know only their position in 3D model. Yeah, they would have to know to move uniformly as a piece. They should know somehow piece they belong to. We can do this by writing position of center of piece to some of the data channels for each vertex. For example, we can use one of UV channels. If they all know center position of piece they belong to, we can move it uniformly. So I've already prepared combining script. Let's look at this. So we have essentially code that combine meshes method. We have our lists of vertices with normals. Vertex is vector 4, its position. Triangles is the index of vertex. UV is vector 4. We will write, and normals is a vector 3. The normal is a direction uh, of surface that it looks, uh, where it looks, we will use it for, it's used for lighting calculations shader. So we have our array of meshes, game objects. We get the mesh filter, get mesh from each mesh filter, and what we do, we um, we get the position, rotation, scale, create from this data matrix 4x4, and we'll need also just rotation matrix. Uh, Matrix will be used to apply to position of each vertex. Yeah, let's look. So first we get vertices, vertices, UVs, and normals from this mesh of each piece, and go through all these vertices, multiply it. So vertex position is local position. So for example, our piece, it would be like kind of like this. It will be like 0, 0, but like some local position x, y. But we need to be like here. So we should consider this our 0, 0 position. And we can do this by multiplying this coordinate by uh, our transformation matrices that has position of this piece, position, rotation, and scale. So we get transform local from local position to like, object from from position of this separate piece to position of like a combined object. Then we add this vertex, do the same with normals, but we use just rotation matrix. And in UV, we write our local positions, position of our piece. So each vertex will know the position of piece it belongs to. So yeah. And we go through submeshes and combine triangles. And we set vertices, normals, triangles, and we have our new combined mesh. I also prepared script, editor script, that actually would allow call this method from Unity editor. But I already have it. So we have our 3D model. Edit. Yeah, let's clear it. Lock it. Take all our shards. Add them to array. Then call combine meshes method. And here our combined mesh. And I can save it. To be able to save it, I've written another editor script. It works for mesh filter. So we can write our file name, and with pressing button save mesh, we can save it to assets with this file name. So let's call it custom bind mesh, save mesh. So here it is. Now we have our combined mesh. We need a custom shader that would actually move each vertex. First of all, I created a great new surface shader. It will look something like this. And based on it, I created custom fracture shader. Uh, I've added some of the things. Here are properties that we will use. Fracture amount. It's the same as we had for our CPU logic. Fracture amount from 0 to 1, translate amount, and rotation, but separately for x, y, and z. We also add this line, vertex vert. It means we'll have custom vertex shader. So vertex default pipeline, you have vertex shader program. You calculate something for each point of 3D model, and then you have a fragment shader. You calculate for each pixel when it's rendered. So we need only custom vertex shader. We transform change position here. So we have our properties that we added, variables for them. Here is our logic. So what we do, we have input data v vertex. It is model position. We call it local vertex position, and we need object origin in world space. To get it, we multiply 0, 0, 0 float 4 by unity object world. Object world is provided as a matrix, like 4 by 4 matrix provided by Unity, and it converts from object space to world space. Then we need our fractured piece of set in world space. Essentially, it's our center of our shard that this our vertex belongs to. So we've written it to texture UV coordinate, fourth UV coordinate. Yeah, let's see. 5 inches. So by default, I choose third UV channel. It goes 0, 1, 2, 3. So we read this position. It is in object space. We transform to world space. Calculate direction from center, as we did here. We got it here. So we take our fractured piece of set minus object origin, normalize it. World vertex position, we take local position and multiply by object world matrix. Relative position would be this. So our vertex here, shard position here. So relative would be this amount between them, kind of like this position from here. Take world vertex position minus fracture piece of set. Translation is how much we will move. So we'll take translate amount, fracture amount, and direction, and we create translate matrix. You don't really have to know how it works under the hood. You just need to know how to make it like this. And to apply it, you need to multiply position by this matrix, and translation will be applied. You will move it. Scaling works kind of like this. So we calculated the same as here with fracture amount. We create scale matrix this way, and we need to create our rotation matrices for like X rotation, Y, and Z. They're created in this way. They don't really have to like understand everything how it works. You can create it the same as an example and just apply it. So then we actually apply it. We multiply our a world vertex position relative. So it will y relative because we want to move around this point. If it would be um, in object space, it would rotate about around this point. So we want to move each shard separately. So first we scale it, then we rotate, um, apply X rotation, Y rotation, Z rotation, and then we apply translation. So we move it. Actually, order uh, order of applying this transformation is important. We can get different results by if we change the order. So then we add offset of each piece, and then we transform it back to object space from world space, because we need to set it. Fragment shader requires it will be sent from vertex shader to fragment shader, and it requires to be in object space. So we need to also rotate our normal, because our, let's see, when we move it, when each piece moves, its surface changes direction. So by default, if we don't do this, if we don't apply rotation for our normals, so let's make it shader, invert, the lightning would be the same, even though it should change when angle of surface relative to light changes. So it's not correct anymore. So when we apply the same rotation to normals, it goes darker because our light is, it's not, so surface gets less light. And so now we have essentially one object, one 3D model. It means we have one draw call, and all the work is done on GPU, so our CPU is free to do some other thing. We can, there are still some problems that you that actually fixable. So in my game, there are no shadows for now. One of the main reasons is performance, but other difference, let's enable shadows for mesh render. By default, shadow will be the same, like it is unbroken object. You can fix it if you implement custom vertex shader for shadow pass. Essentially, when um, you now um, when you render shadows, do some calculation, you use separate pass, and it calculates, renders your object with this pass, but it still uses a vertex shader that doesn't do our fracturing. So essentially you will have custom shadow caster pass with the same logic as you have here. Mostly you can copy. You will have correct shadow, and you can like improve it, change it, add more things. Actually, when we break it, so broke this, each shard 3D model actually consists of two submeshes. Blender. So one submesh is outer, kind of like shell, and other is inner. So we can use it somehow. When we combine it, we can write some additional information. For example, here we use our UV coordinates to write a position of each chart, but UV is vector 4 and we use only vector 3. So we can write to force uh, force coordinate 0, for example, is inner mesh, and like 1 if it's outer mesh, and based on this we can add some like glowing effect, shader or something like this, whatever you want. So, and you can have a bunch of these objects, so you'll have better performance. So I hope this was helpful for you. I will add all the code to GitHub so you can follow the code. You can look at this. If you like my game, you can play it on Android, on Google Play, or you can, it will be soon released on Steam. You can add it to wishlist. Yeah, thanks. Goodbye.